All right, welcome back. So in this video, we'll go ahead and implement the naive string search algorithm. So I already have a snippet created. Do this wherever you prefer, Sublime, some text editor, as a snippet yourself. It doesn't matter. So I have one called search naive string, and I'll close that for now. First, let's just define the function. So it needs to accept two strings. So I'm going to call it naive search, and it accepts the long string and a short string, or long and pattern. I've also seen that, or pattern like that. I like short though. And then the first thing that we'll do is just do a sample call down here. So naive search, and let's say, for example, that we would be calling it with maybe Lori lolled, LOL'd as a verb, and we're searching for LOL in that string. Okay, so first of all, we're going to need to get some loops going, as the pseudocode mentions. Loop over the longer string, and then nested inside, loop over the shorter string. So let's just start with the most basic loop over the long string. So for var I equals 0, while I is less than long.length, I plus plus. So that should give us every I, if we just look at it. I'll execute this, make our console a bit bigger. Come on. All right, so we get 0 to 10. There's 11 characters in there. Then let's do the same thing, this time for J, or whatever letter you prefer, but J is the standard one, H-I-J-K, yes, yeah. Okay, for var J equals 0, J this time is less than short dot length, J plus plus. It gets a little confusing once you start working with I and J, keeping track of which one is which. So if we just printed out I comma J each time through, those are going to be numbers. So why don't we do instead, let's do long of I, so we see which character we'd be referencing, and short of J. Now we're going to get a lot of prints. This is a nested loop, so we're looping 10 times here, but each of those 10 times we're looping 3 times for the LOL. So if I clear this out, I'll make this larger and try it again. All right, so you can see what we get here is basically we start with L on both of them, L and L. And then the inner loop goes to O. So we have L and O, and then L and L again. And then we move to O, and we start over, O and L, O and O, O and L. Okay, so what do we actually want to do rather than just printing them out? Well, the first thing that we can do, let's forget the fact that I and J are numbers, and let's just say that they're the letters exactly. It's a little easier to talk about. So let's say that I starts as L, and J also starts as L. So remember that I is our outer loop. So I is going to stay L as we progress through LOL, if that makes sense. As J increases, it has to increase 3 times and then reset in order for I to increase once. So we start the loop. I is L, J is L. We compare them, looks good. Whenever there isn't a match, we break out of this inner loop and we move on to the next iteration. But let's just focus on, in this case, there is a match, L and L. So what do we do next? Well, the next comparison is still going to be L, but it's going to be compared to O, because we're moving, basically J moves on and it becomes O, because we're looping through this first. But that's not going to work to directly compare O and L, because we know that's not a match. So what we want to compare it to is one more than L. So as we move through J, we want to also look ahead in I, even though I is going to be stuck at 0, if that makes sense. As we look through this, as our short pattern, LOL, continues to loop, we're still comparing to L each time. So instead we want to look ahead, and the best way to do that, or one way at least that I'm going to do it, is by adding I to J. It's kind of confusing. But now if we go back to numbers, and we say they both start at 0. Okay, so there's a match. Now J goes up to 1. So we're going to compare LOL of 1, which is O, to this string, Lori lolled, but instead of 0, we're going to add them together. So where we were before plus where we are now in J, which means that we're going to look ahead to O, because that would be index of 1. And so that's a match. Next time through our short string, we're at index of 2. So we're going to compare this L, and we are going to add 0 plus 2 to give us index of 2 of this string, looking ahead, and it's not a match. So then we break out. That means that we start again at L. But then once we get up to here, which is what? Index of 0, 1, 2, 3, 4, 5, index of 6. So in the scenario where we are here, index of 6 in the large string, index of 0 in the short string, there's a match, right? Those are matches. So then we move on. In the short string, j goes up by 1, and it now becomes 1. But we don't want to compare Lori-Lold of index 6. We want Lori-Lold of index 7. We add them together. So hopefully you can see the approach. We're looking ahead. And to do that, it's not too bad. All we do is add I and j together and access, using that new index, access the long string. So here's my approach. Instead of console.logging, we'll just basically check if the short string of j is not equal to the long string of I plus j. Now, if that happens, then we'll break out. So let's make this a loop. I mean, a conditional. Like this. So this means break out of this short loop and start on j again at 0. So anytime there isn't a match, we're going to break. So if I add this console.log in there now, where I'm printing short j and long I plus j, I'm going to clear out like this, and let's see what we get. Okay, so our comparisons, we start with L and L. That makes sense. There's a match, so we don't break out, and we move on to O, and we compare O to the next character, which is O, and then there's a match, so we move on again to L, and we compare it to R, in which case there wasn't a match. So if I added in a console.log here to say break and reran this, you can see what happens. So it looks like there's a match, L and L, O and O, and then there isn't a match, so we break. And when we break, what is happening there is that j is being reset. This inner loop is going back to 0, meaning we start at L again. But the outer loop, I, moves on. So now we're starting here at O. So after that break, we do L and O, and that's not a match, so that's a break. So then we move forward again. This time, we're talking about R and L, and that's not a match, so we break. We keep going until finally we get here. And there's a match, so then we move on. And there's another match and another match. But what do we not have right now? We're not actually incrementing any sort of counter when we find a full match. So we found a full match right here, LOL. Those are three pairs that match correctly. So what we need to do is make a variable up here. Let's just call it count equals 0. Now, when should we increment count? Well, the way that we know that we have successfully made it through this string, because if we get to this last character and there's a match, if we've made it to that point, that means that j is going to be whatever the last character in the short string is, if that makes sense. So if we had LOLD, L-O-L-E-D, we know that we've finished if j is 0, 1, 2, 3, 4, if j is 4, or in this case, if j is 2, if we've made it to that point. So we can just add a conditional check, just do an if, and then we just check if j is equal to the short string dot length, but minus 1, because the length is going to be greater than the index. If that's the case, let's add 1, let's do plus plus, like that. And then at the end, let's return count. Let's see, how many braces do I have? So that's conditional, loop, loop. Okay, here we go. Okay, so let's see what happens now. So why don't I add a console.log in here, found one. Clear my console, rerun the whole thing. Let's try that again. Okay, so if you see, we have the same exact thing, almost a match, but there's not, so we break, keep going. But then, hooray, we found a match, and so this code is printing. So count is going up by 1. So if you get this, if it works for you, or if you had a slightly different solution, but it's working, that's all that matters. If you have 2 loops and you're getting it to work, your logic can be slightly different. You could work from the end, for example. You don't have to work from the beginning forward. You could work backwards. That doesn't really matter. But if you have it working, great. If you want, you can stick around and we can walk through this one more time just to see exactly how it works. I'm going to shorten this up because, like some of the other solutions, we can put these on single lines, make it a little nicer, like that. Same thing with our second if. Move that up here, just like that. And it still works. Should still work at least. Are we getting it results printed? Come back, console. Yes, we're getting 1. Cool. All right, so if you want to stick around for the extra walkthrough, let's try it one more time with something different. Let's try it with LO, which in this case, we should get 2 matches. Is that working? Yes, we get 2. All right, so what's happening here? Well, we loop through every character. For example, L is where we start. And on the second string, we loop through every character. So we start at L. And immediately we check if this character doesn't match I plus J of this character. So I and J are both 0. So this means we're checking the first characters together. 0 plus 0 is 0. So if they don't match, immediately break out. And that means that we move on and that I is now right here. So if they do match though, which they happen to match, what do? Well, since we're still in this loop, we move on. J is now pointing to this, but I is still here. So now we add those two together. J is now 1, I is still 0, so that gives us a total of 1. And we compare this to that, and there's a match, at which point we increment count, because J is equal to the length of the short string. That's how we know we're on the last iteration. J, in this case, would be equal to 1, 0, 1. When we get to 1, and we haven't broken out yet, if we get to this point, that means we found a match. All right, so then it repeats again until it finds this match. So hopefully that's clear. And if we try it with something that isn't in there, like pop, we should just get 0. And we do. So we don't have to account for anything because we have this count variable. It's unlike binary search, for example, where we had to handle errors, not errors, but we had to handle those edge cases. If we don't find anything, we count 0. All right, so that is an implementation of naive string searching. Next, we're going to see a better implementation of a different sort of string search algorithm. Definitely a little more complicated and longer, but it will be fun to talk about, I think.